so take a look, see if you guys can figure out which one of these is an exponential function. Good, Brianna, you're right. All right. It's the one on the right hand side, this one right here. How did you know? Good guess. Okay. Right. This one is the exponential function because the x is in the exponent. Right. If you guys graphed this, you graph y equals x squared. Anytime we saw an x squared, you guys got a u. What kind of shape is that? Parabola, good, or quadratic. Nice job. Okay, so this one's not an exponential function.
That was part of the geometry class. Both times.
All right. So basically, guys, when you see an exponential function, the x is in the exponent. So today what we're going to focus on is just graphing these, how to pull up a table, what they look like, and kind of one special thing. I don't know if you guys got into it last year. So if I was going to graph f of x equals 3 to the x, what does f of x mean the same thing as? Any ideas? I want that to confuse you. It's a function of x. What a great man. It's so good. Yeah, that's great. Holy cow. That's like a super definition. That's great. I wasn't expecting that. That's so good. Okay. And f of x, it is a function of x, and it really just means the same thing as just y. Right? Nothing fancy. Yeah. So this means the same thing as y equals 3 to the x. Okay. So if you guys see like f of x, don't panic. It's just the same thing as y. So now if we're going to graph that, okay, go to your y equals button. Make sure our calculator is in the degree mode. So if you guys go to the mode button, right, we all know where the mode key is. Right, arrow down to degree, highlight that, and then you're all good. Okay, so let's see. So we're going to do 3 to the x. Make sure you guys put a caret, right? The x is an exponent. Please make sure you arrow it up, right? And then graph it. Oh, you know what? Sorry, my other kids were doing stuff with radians and trig. So go to zoom 6 if you're borrowing a calculator from me. Zoom 6 if it looks funky. Yeah, if you want to do it anyways, that's fine. That'll always make it look
the same.
Oh, yours is fine then. It's normal to begin with. Okay. All right. So if you guys are going to graph this, is it okay just to do this?
Yeah.
Yeah. You think so?
No!
Oh my gosh, we can't do that.
Why not?
No, because we can't tell the point.
You have to go to the second table.
Good. Okay. Good job. Second table. Nice job, Matt. All right. So we want to make sure that things will fit on our graph. Can we graph 243?
Yeah.
No. So let's
have to say no points.
Yeah, but 243, we're not even on that.
You also can't graph 0.1111.
Good idea there. Okay, so let's start at 0, then we'll talk about what's going on in this part. I don't think you guys probably got this involved in algebra and geometry, like what happens over here. Maybe. What?
I couldn't tell you even if we did.
Well, maybe we'll learn it now. I don't know. Okay, so what do we got? We got 0, 1, 1, 3, 2, 9. There we go. Now, Matt said something really nice about the other values. Now, can we get exactly 0.333?
No.
No, right? We don't know where 0.111 is. These numbers are getting super, super, super tiny. See how it goes like 0.0, 0.00, 0.00. Yeah? Okay, now this though is something kind of weird, right? You guys will see this come up once in a while. Your calculator kind of runs out of space. Okay, so what it does, this e to the -4 means scientific notation. So you're taking really 4.6 times 10 to the -4. Does anybody remember what way you move the decimal point?
Right.
Left. If it's negative, you go left. Good job. 4 spots. So if I took my decimal point and I went 1, 2, 3, 4, right, this would be like 0.00046. Okay. So, yeah, that is scientific notation. Right. So what happens is your calculator kind of says, all right, I'm going to shortcut this, so they write it this way instead. Okay. But really, now this is a very, very small number. Okay. So if you guys see that e with a negative, it just means scientific notation. Right. Going back to what Matt was saying, we can't get exactly that special point, but we're going to estimate. Okay. If you went negative 1.3, maybe somewhere here. If you went negative 2.1, it's almost touching the line. Just give it an estimate. So the big thing that's very important, let's look at our calculators. If you guys continue in the negative direction, are we ever hitting exactly 0? It'll never hit 0. Good. Did you try it on yours? No? Right? It will never hit 0. You could keep going, you know. Don't be that person that goes like negative 300 and that's the calculator. Right? I think eventually it does like, you know, say it touches, but it doesn't. Right? There's something going on here. It'll never cross this line. Okay? So when we do our picture, what we want to do is just be careful that you're not going to cross the line. Right? And then we have to put a nice little label on.
I think the one you drew looks closer than that.
Yeah, it might be. Yeah, I don't know. Alright, why don't you guys try the 1/2 to the x? And we'll see kind of what we notice about them, maybe where our lines are going to cross. Make sure you put the 1/2 in parentheses in your calculator, right? And then make sure you put a caret x. Try it out, work with a partner. Make sure you guys are both using the calculator. Oh. What? Oh.
I don't know. I wasn't here to do that.
Why is there some dog?
Make sure at least you get 1/2 caret x. 1/2 to your center. Okay. That's fine. Okay. The second graph will give us a table.
I don't know. That's
Two dogs. Carrot.
no. Like it biased me a little bit, but I did do that. So.
All right. So did you guys get something that looks like this? Hopefully.
Yeah.
Okay. Good. What do you guys notice if we had something that was smaller than 1 and something that was bigger than 1 as the base? What happened with the direction? It reversed. Good. So when we have bases that are going to be bigger than 1, like this 3, it's going to come down from the right. And if we have a base that's smaller than 1, it's going to come down from the left. Does anybody know where these two lines are going to cross?
0, 1.
0, 1. Awesome. Good job. Perfect. Sure. What other? Oh, the other thing they could ask from you guys, maybe on like an SAT. Does anybody know what line this reflects around? Nice. You're on a roll today, Brandon. Good job. Reflection of the y-axis. Great job. Okay, just gonna reflect on that one. Good. All right. Now, something that might be new for you guys. I just don't want you to panic when you see it, more so that you're able to find where the key is. You might be able to see something where you're graphing something called e to the x. Right? And e to the x is going to be used when you are working with things that are compounded continuously. Do you guys remember growth and decay? Like, if you deposited money in a bank for 5 years at an interest rate of 5%, what would you get at the end of 20 years? Well, yeah, I don't know. I just made that up right now. But
In geometry.
no, you learned it back in probably 8th and 9th grade. No, maybe a little bit. We're gonna do it again this year.
What did you say again?
Like if you deposited money in the bank, like an interest rate, they asked you like how much you would have at the end. Maybe.
I don't think it'd ever be at 5%. Will it?
Well, you probably have interest of like your loans at 5%.
Oh.
Not like your bank, unfortunately.
Yeah.
That would be way better. So we're going to be dealing with this E, right, when we go over that stuff. Right now in your calculator, all I want you guys to be able to do is physically graph this, right? Find out where the key is. So if I had you graph y equals e to the x in your calculator, you're going to go to your y equals key. Make sure you go and find this, right? Your e button is if you guys do second, there's an ln on the side. Second, ln. Underneath the LOG button. Make sure you find it. Second, ln. Then she'll get it. Second, ln? Yeah. Okay, so you guys should get E. Okay, then put your X's. Second. And then the ln button is right underneath the log key. Okay, that should give you guys an E. If you look on the top part of your calculator, there's an E that comes off like it's right above it. And then just hit graph. Does it look pretty much the same thing? Yeah. No, you have to put the X in. You have like the little line. Yeah. No, you gotta put that in. Right? So that's where your E key is. Make sure you and your partner both can see how to get that. Right? We're gonna be working with B and E. I have no idea. Alright, last thing I want to do real quick. You guys are almost done. You have no homework tonight. Okay, so going back to what Matt said, just flip this over real quick. We don't have to do too much of this. Right. What I want you guys to do, graph this f of x equals 1/3 to the x. Okay, put that one in your calculator and let's graph that. And then we're going to talk about kind of what's going on in it. Right, when you guys get on this side, I mean, you can really just only estimate. Alright, so Matt noticed that these numbers on one side get super tiny. And Brandon said it never crosses 0. There's something special with a exponential function that happens. It's called an asymptote. Have you guys ever heard that word before?
Yeah.
Asymptote.
You did?
Yeah, maybe that, I don't know.
Let's add more than one definition.
So the asymptote is, what that really means is that, think of it like an invisible force field, right? So if Jess is the, we'll say the x-axis, and I have a function, I'm going to get super close, but you can never cross it. Think about it like you get zapped back, right? It's like a force field that my graph can never cross. So when you guys see these asymptotes, right, it'll never cross that line, like ever. Yeah, that's basically it. It never crosses the x-axis. So that was it today. I want to make sure you guys can actually physically put stuff on a graph, and that's it. Did you guys get that stuff? How do you do with putting things in a calculator? If you want to graph the last one, you can. Not a big deal though. Alright. So you guys can mark this or that you can physically graph.